Based on this unit, you are now able to identify cases where the normal distribution is relevant and where not. You can calculate probabilities for normally distributed random variables, and you are able to use the normal distribution to estimate probabilities that are binomially distributed. You are able to read and use the standard normal table to calculate these probabilities and understand the relationship between the number of standard deviations on a standard normal table and the number of standard deviations in the actual normally distributed data. The normal distribution received its own unit. It is that important. But let's be careful as to why the normal distribution is so important. Remember that there is no such thing as a normal process, but there is such a thing as a binomial process, and a Poisson process, and an exponential process. One should never assume that the values of a random variable for a particular population are normally distributed. It is certainly more likely that they are not. And in all the problems that we solved, we had to assume that the population was normally distributed for us to solve the problem. There was, however, the exception for those cases where the underlying distribution was binomial. There is a mathematical link from the binomial to the normal distribution that allows for this estimation. Otherwise, we need to be told that the distribution is normally distributed. Always remember that a probability problem is only a probability problem if you know all there is to know about the sample space or the underlying probability density function from which the data are generated. If the problem speaks of taking a sample, then it is not a probability problem, because a sample, no matter how well drawn, is only a reflection of the underlying population. It remains for the next unit to discuss just how samples can be used to make inferences about the population from which they came. And it is now time for me to be true to my promise that we needed probability to do statistics. Inferential statistics relies upon the probability rules and distributions we have just studied. In inferential statistics, we will convert the statistics problem, where we know only the slightest about the population data, back into a probability problem, where we know all there is to know about the underlying distribution. And spoiler alert, the distribution that we rely upon for virtually all of our needs will be the normal probability density function.